Joining us here at Olds Performance and Machine. Hey, we're back on these iron F cylinder heads. For that 496, we talked about how the surface finish was extremely rough, that equivalent to the texture of a file. So we went ahead and milled that surface, and we do that with our Comac i1000 rotary broach. And we have two different blades. We got a CBN blade, which leaves a mirror finish here. Changes the RA, and it's great for a gasket. And you could see right there the reflection of my pinky in the surface there. Pretty much a beautiful smooth finish that machine leaves. It's great for the head gasket. We'll get no compression that will blow by within the cuts of like a carbide if you ran a carbide machine fast. And that's what was done on these heads prior. It was a machine that held carbide, and the feed rate was way too quick. So now we got a beautiful surface on this head, and it's going to seal very well. We also went ahead and, as mentioned before, we brought that valve job higher in the chamber by using valves that were a little bit oversized. We've got a 209 here on the intake and a 1705 here on the exhaust side. So that's helped it out. We still have room in here, plenty of room in here, so they're not going to clip. There's a minimum which we like to see, and that's about 38 thou, 28, 30 thou. And we have that, so that's not going to be an issue there. Talk about springs. This motor had a problem, obviously. They went wrong in setting up or choosing a spring. This is the old spring for this thing. It was set up about 140 on the seat. It was a mechanical roller. Approaching 600, I believe, was what we spoke about. This thing had lifts in it that were 600 plus in this thing. So now we have a decent, what we would consider a decent lift for the street. And we chose to use a cam that sits somewhere around the 550 area. And that's great for the street. There's not going to be an issue with that. They're not going to have any sort of valve train issues there whatsoever. It's something that we just like to stay a little bit more conservative, have less valve train issues, especially if it's a street-driven show car or something of that nature. Okay, so talk about springs. This is our new spring right here. It's a pack spring. It's a great quality spring here. It's got a small retainer. We actually went from what was on it, which was a titanium retainer, to a steel retainer. And believe it or not, we usually do vice versa. We usually go from steel to titanium. In this case, we went from titanium to steel. But yeah, what's unique about this is that when weighed on a gram scale, this steel retainer is actually lighter than this titanium retainer. All in all, when we put it together and get it on a gram scale, we have gram weights that, when combined, spring and titanium retainer, which is what was on it, migrating to this new pack spring with the steel retainer, we're a difference of 20 grams. We're 20 grams lighter here with this pack spring and steel retainer than we are with this particular spring and a tie retainer. The actual gram weights are right here. Spring combined with retainer prior to 157.2, and the new setup is 136.3. That's 20 grams right there. That's a significant difference when you're talking about inertia and valve weight or spring weight that's hanging on a valve. The new springs, we went ahead and we set them up at 165 pounds on the seat. They got a rate of 440, which is nice. Perfect for this motor for a mechanical roller cam, and that's what's in here. That's what we decided to do. We decided to continue on with the mechanical roller. It gives great valve events per piston placement at given crankshaft degrees. The stability is right there. Unlike a hydraulic roller, when you get into the mid to upper RPM, you don't necessarily have the piston in relation to the valve exactly the same all the time as it flutters. And that's that cushion of oil in a hydraulic roller that it rides in. So this is a mechanical operation here as far as the valve train, and it'll keep valve events stationary. So we got a rate per inch of 440. That's enough to control the valve. We're in at 1.920 for installed height and 165 pounds. The old spring right here, they had it in around 140 pounds. And between the combination of the weight and the additional lift exceeding 600, it just did not control the valve well, and great possibility. That's why it tagged the valve and laid the valve over and stuck the valve, whereas this motor was only running on 7 cylinders when we got it. And we believe when the customer got it, it was only running on 7 cylinders. We believe that it was tagged right on the dyno. Anyway, so we appreciate you guys tuning in. Like, share the video. Tell your friends about our company, Olds Performance and Machine, Olds Performance Products. If you have any questions, just give us a call, 1-800-382-1320. Once again, thanks for joining us.